All right, welcome to the webinar on data collection. We'll just give it a minute or two for people to trickle in. One more minute and we will get started. Okay, well, let's get rolling here. Hello, my name is Ian, and I'm a customer success engineer at Propeller. I'm joined by my co-host Ben, also a customer success engineer in the UK. We're going to be going over data collection today. So we'll have the ability for you to submit questions throughout the webinar. Ben will be fielding those, and at the end of the webinar, we'll do some open Q&A. So looking forward to that. Can't wait to hear your questions. All right, so data collection for a Propeller PPK, that's the post-process kinematic workflow. So what we'll cover today are the survey process limitations, ground control and AeroPoints, how to place AeroPoints, recording and uploading AeroPoint data, flight planning and airspace, resources review, we've got a lot of those, and some drone-specific information. We will not be covering drone-specific information, sorry, because we can use quite a few different drones for the PPK workflow. So survey process and limitations. So this is kind of the general workflow. You're going to be out in the field. You're going to have to place your arrow points strategically throughout the job site and make sure that your existing ground control is visible if you have any. Then we're going to fly the drone and do some data collection with that with our preset missions. And then we're going to upload the AeroPoint data to the system. Then we'll upload our drone survey data to the system. Processing the service licensing agreement is 24 hours, but you should likely see your survey before then. And then everything is in the platform ready for you to analyze. So the ideal drone survey. So it's, good data in, good data out. So we want good imagery with high resolution, um, anything below 400 with these drones these days is typically going to be all right, depending on your job site. Good clarity, we want that shutter speed and ISO combination to be dialed in. We want good overlap. That's really key to a good photogrammetry data set. And we want to make sure that we're getting 100% minimum flight time, typically 10 minutes for any RTK capable drone. And then we really need good ground control placement. We need even distribution and sufficient capture time on those smart ground controls, the arrow points. So this triangle here is, if you've ever taken a photography class, you may have seen this, but the photography element is really well summed up here. We want a good balance of these keys. So ISO, aperture, exposure, and shutter speed. And we have all of these settings really dialed in and available to you in help articles for quite a few drones and sensors. So don't let this be intimidating. And this is kind of why. So the importance of shutter priority here. So 180, 1 250, 1 1000th here. you can see that, 1/1000th of a second, this is that clarity that we're really shooting for. A lot of the drones that we recommend have a mechanical shutter, so this really crisp image clarity is easily obtainable, and we can dial it down slightly for, things like flying in overcast or winter conditions if you're in those northern countries. So ISO, you can see this is ideal, again, nice and crisp. The higher the ISO is, the more grainy those images get, and then it becomes more difficult for images to be stitched together. So that's the importance of ISO. We really want to avoid this really noisy, grainy effect here. So photogrammetry does have some limits. There are going to be situations when you have to fly over water, especially a lot of our aggregates customers. We can always clean up this noise with terrain cleanups and some filtering, but typically photogrammetry is going to work best on clean, consistent features. It's great on, stockpiles, haul roads, landfills, asphalt, dirt, and all of those predictable surfaces. When we get into dense wood lines of tall trees, um, things where it's indistinguishable features, you can imagine a tall tree canopy on a windy day, kind of swaying in the breeze. It's really hard for photogrammetry to lock those pixels together when all of the images get stitched. And so, we can still fly over this type of terrain, but we want to make sure we're getting key points in there like roads, building pads, things like that that are, adjacent to those tree lines where we can stitch all the images together. So flight planning in airspace. So we make it really easy to see, how prepared you need to be for any given flight. You can see in North America here where I'm located, uh, everything east of the Mississippi is very densely covered. And then as we get out west, we may need to consider using the known point workflow. But really, we want to use our links to the propeller correction network here, which is what you see. All of these red circles are CORS base stations to check if we're covered for just general AeroPoint placement. We also want to make sure we're checking for flying restrictions, that the drone is charged up, checking for drone updates. Maybe we have some firmware updates that need to get knocked out before we do some data collection. And again, this propeller correction network map should always be consulted before going and flying a fresh project for the first time. So there are airspace restrictions that we might run into. DJI FlySafe is a great resource to get a good overview of where those flight restrictions are, if there might be anything impacting the data collection on your project. You can go to DJI FlySafe and then check out the airspace restrictions that are demonstrated there. DJI used to restrict their drones from taking off. Um, if you were in a designated zone, a restricted zone, but now they do not. So it is really on the operator, the pilot, to make sure that they're operating legally wherever their project exists. So I don't know if that has changed elsewhere across the globe, but in the US and I believe in the UK, Ben might be able to back me up there.
Yeah,
That DJI will no longer be restricting takeoff in these zones. It is really on the pilot to ensure they are flying legally.
yeah, that's exactly the same. UK and Europe is the same as that.
Awesome. Yeah, thanks, Ben. So legal considerations, we always want to check that airspace. We want to make sure we're complying with government restrictions. And then in North America here, we have what's called a LANCE authorization available through the FAA. We have help articles and can assist people with all of these situations. We've got a lot of resources to support you with there. The FAA Part 107 waiver is the legal requirement in North America, and that's obtained by taking a test with the FAA, and then you can very easily renew it every 2 years after that. So airspace legal considerations continued here. We've got some good resources that we just want to highlight. So OpenSky, you can verify the airspace permissions in your flight area, any kind of emergency restrictions. It's good to check these things before you go fly, building that habit of checking airspace and any kind of temporary restrictions that may pop up. One example is if diplomats or national leaders are in the area, they typically will put up a restricted operating zone for that time period, and you may not be able to legally fly. So just always good to check in on those things. For the UK, we've got Altitude Angel here. Feel free to drop any questions on that in the chat. Ben is located in the UK and fielding those questions right now, and is also knowledgeable about some EU country flight restrictions. So again, it is up to the pilot to make sure that you are flying legally and within regulations of your area. So ground control and AeroPoints. So ground control points versus checkpoints. This is an important distinction that we like to make. So a ground control point is going to be contributing to the construction of the model. A checkpoint is going to be a coordinate taken on the surface of your project, and that coordinate will get uploaded as a CSV file when you upload your drone survey and AeroPoint data. And that is just going to check against what the model construction has come back with to what you collected out in the field with a rover, for instance. So important distinction there. We do not need a visible target for checkpoints, but we do need a visible target for ground control. So anything that can be visibly identified in the drone imagery, that can be considered ground control if we have a coordinate to that. Anything that is not visibly identified, we can upload as a checkpoint. Very easy to do in the uploader. So we're looking for nice, clean, distinct intersections or points like this kind of reticle target here, this cross. These are great examples. Try to avoid putting those really thick, 10-centimeter wide lines on the ground with a vague intersecting point. We can get pretty dialed into the pixel when we're assigning these coordinates to these targets here. So keep that in mind as you create ground control targets on your project. So this is the AeroPoint. This is an AeroPoint version 2. Very simple to use. Huge improvement over the AeroPoint version 1s. We've got one button operation. They're pretty rugged. I mean, it is a piece of sophisticated GPS equipment, but they are proving themselves over the test of time on projects worldwide. It's pretty impressive that what a lot of these live through. The AeroPoint 2s have a charging port, so you can make sure before you go and do your data collection that they've been charging the night prior or earlier that morning. They also have a solar panel to keep them running for 8 hours of collection time out in the field. That GPS antenna is located right in the intersection there of the gray and black squares. They're pretty lightweight. You can throw a backpack of 5 of these on and go walk around your job site without any real breaking a sweat typically. And they've got a huge memory. So I get asked all the time, how frequently do I need to upload my AeroPoint surveys off the AeroPoints? And it's honestly, you can have about 100 surveys on an AeroPoint before we need to start offloading that data to free up some space. So, and they help. The design on these, is pretty great. They can sit out in high winds without really shifting around. We've got a nice angle on the side. They're made of dense foam and just a very durable, good product that we like to use with the PPK workflow. So a couple things for AeroPoint 1s and AeroPoint 2s. If you find working AeroPoint 1s out there on the secondhand market, I encourage you to supplement your AeroPoint 2s with those, because if they're still working, they're still working. But there are some considerations. We've got AeroPoint 1s have a collection time of a minimum of 45 minutes. So you need to place it in a good area, turn it on, and let that thing cook for 45 minutes. Most customers will typically complete their drone data collection in that time. I would say for the majority of projects being flown. The AeroPoint 2, though, it only needs 10 minutes of collection time. It's observing more satellite constellations, so far reduced collection time necessary there. And that's really convenient because we have a minimum collection time of 10 minutes on the drones as well as the AeroPoint, so that really dovetails nicely. But if we have a mixed fleet, like supplementing AeroPoint 2s with that 8-hour collection time versus the AeroPoint 1 5-hour collection time, we still need to default to that 45-minute collection time so AeroPoint 1s can get good solid data for you. So AeroPoint placement. If you can get AeroPoint placement dialed in on your projects, you'll have many successful flights and very few headaches, if any. So AeroPoints with the PPK workflow, we want equal coverage. So we want good distribution horizontally as well as vertically. This little 3D model here demonstrates that perfectly. We want to make sure we're hitting the highs, the mids, and the lows. We want them to be on relatively flat surfaces, try to keep them off steep angles of more than 20 degrees. And then we've got some coverage considerations here. So we want that good equal coverage. 1 to 3 AeroPoints cover 150 acres or 60 hectares. Additional 1 to 2 AeroPoints per additional 50 acres is what we recommend. And this will typically provide good ground control for the most complex and dynamic, terrain relief type job sites out there. So one very important element to this is we want them to have a clear view of the sky. So we really want that 15-degree cone. It's a piece of GPS equipment. It's observing satellite constellation, satellites directly above, but also far out on the horizon as well. So that 15 degrees is really crucial. Easier said than done on a lot of projects, especially if you're in like a pit mine or something like that. We just try to put them in the best area possible, but we are always shooting for that 15 degrees. 50 feet from any kind of obstruction. From the pickup truck is typically the one that people forget to keep the AeroPoint away from, but we'll know after your first flight if you're dropping it out the pickup truck and not driving a few vehicle lengths away. Trees, buildings, vehicles, power lines, chain link fences, anything that can cause GPS interference, we want to keep well away from the AeroPoint. It is a sensitive piece of GPS equipment. We want to avoid that multipathing. GPS signals are radio frequencies, and we don't want a bunch of frequency bouncing around, coming from different angles and hitting that antenna in the center there. So here's the don'ts that we see quite a bit. Don't put them in high traffic areas. One, they can get run over. Sometimes they still work, sometimes they may not. If a big rig like this were to run it over, it just depends. But what it will do is if it's next to a busy haul road or anything like that, where we've got like 777s on a mine driving by regularly, that may cause some GPS interference, so we want to avoid that. We don't want to cover or obstruct them. The rover is typically the big one that we'll see in photos still on top of an AeroPoint while that data was being collected. The unlevel ground, so we wouldn't want it to be, over a curb and gutter kind of situation. We wouldn't want it to be on a pile of large riprap or something like that. We want it to be on, some relatively flush surface with the bottom of the AeroPoint. These are both fine examples of the type of ground that you want to put your AeroPoints on. We really don't want AeroPoints to move during the survey, so we want them to be stationary and safe from any kind of interference or activity during data collection. And if you are going to shoot in the known point or your AeroPoint location with the rover, highly encourage getting one of those little spike caps to go over the top of your rover so that that's nice and flush. That GPS antenna is covered by some high density foam, but it can be pierced by a pointy rover stick. So keep that in mind. So the workflow do's. So make sure AeroPoints are fully charged. We've got that charge point on the version 2s now, so that makes that very easy for you. They do come with a supply charger. We want the arrow points placed on the ground first, then set into a logging mode. So we don't want to hit the button and then put it on the ground. That can introduce some error. We want to put them on the ground and then hit that button. The LED light pattern will change there. You've got a little key as to what those lights mean on the arrow point itself. And then we want to switch the AeroPoint. I'm sorry, we want to use the AeroPoint app. We'll touch on that a little bit later. But the AeroPoint app is a great tool when you're within Bluetooth range of the AeroPoint. After you've turned it on, you can verify that that AeroPoint is indeed in a logging status. And it'll also give you the GNSS signal quality. So you'll have like a donut on there that should be green. But if you have a red section of that donut on the AeroPoint mobile app on your phone, it's a good indication that you should turn the AeroPoint off and relocate it. And then switch that AeroPoint into network mode. So just like we want it recording before we do our data collection after we place it on the ground, we want to hit that button one more time before we pick it up and send it into a logging mode. That way, all of the data that's being collected is from a stationary AeroPoint on the ground. And then we want to pick them up in reverse order. So if I walk across my job site or drive across my job site, placing arrow points 1, 2, 3, 4, 5, when I'm done with my data collection using the drone, I've got the drone all put away. I've let the arrow points hit their minimum collection times. I want to go back 5, 4, 3, 2, 1 and pick those up. This is going to give us a nice pyramid of collection time. So just a reminder, Ben's mining the chat room right now. So if you want to shoot him any questions that have come up, please do so. So here's that pyramid. This is a result of placing our arrow points 1, 2, 3, 4, 5, 6, and then picking them up 6, 5, 4, 3, 2, 1. This gives us that nice data collection pyramid here, and this allows all of these other arrow points to be referenced back to the arrow point that's been collecting and refining its position for the longest period of time. So we call that first down, last up. When in a network mode, once we turn them off, we go do that 6, 5, 4, 3, 2, 1. The arrow points will automatically go into a networking mode. They'll be looking for a Wi-Fi connection. There's a couple ways to do this. One is the classic, we call it propeller, where you'll set up the network on your hotspot on your phone called lowercase propeller, and then you'll provide the password to that network as lowercase propeller. The arrow points are automatically looking for that gateway. It'll push the data through there. Or you can set up a customized hotspot on the mobile app. So for instance, if you don't worry about uploading your AeroPoint data immediately out in the field, you're just going to do all of that when you get back to the office, we can set up a 2.4 gigahertz Wi-Fi connection, and you can just upload everything in the office on that nice stable connection instead of out in the field, potentially missing an AeroPoint upload or something until you realize that you don't have it in the system when you're uploading your drone survey data. So a couple options there, very well covered, and got some convenient options for you. So this is that AeroPoints app. This is only compatible with the AeroPoint 2s. The AeroPoint 1s don't have this connectivity, but the app is going to save you a ton of headaches out in the field because of the things that we just covered. So it's free. You can download it on the Google Play or the Apple App Store. It's a great diagnostic tool. It's going to allow you to see things like battery, the file information, the length of capture, the upload status of the AeroPoint, the signal quality before you start flying your site in case you need to relocate your AeroPoint. This right here is the one that I really stress for all of my customers. Make sure you're getting that GNSS signal quality before you walk away from that AeroPoint. It takes 30 seconds, but it'll save you a lot of time in the long run if that AeroPoint is potentially in a bad location. It's not required, but I highly recommend the app. It is a great tool out in the field. Very convenient. So all of this information has to go somewhere, and it's going to go to the AeroPoint's dashboard automatically for you. So it all gets neatly organized as soon as it's uploaded into the system. Your AeroPoint surveys will be located right under your AeroPoint group right here. And you can move AeroPoints into other groups if you want. There's a ton of functionality built in here. You'll have separate permissions set up, and then all of your AeroPoint surveys will be available down below, and you can select those to upload with your drone survey data. So you can verify that they've uploaded here. You can merge AeroPoint surveys and download that data. There's several different download options that are available from all that GPS data that's been collected. Check on that battery status, make sure they're good to go for the next survey, and then you can give other users access all in the AeroPoints dashboard. That's just scratching the surface, but it's a good overview of how you'll get started with this. So speaking of getting started, resources. Favorite button in the platform right here is this question mark. This has access to all of the resources that are available to you. So by clicking on this, we have access to the Help Center. This is the knowledge base, and this is probably 500 articles deep now. They're short, sweet, straight to the point, visually rich articles. So we get really good feedback on those. They're professionally done. And then we have Propeller U. So this is our video content. This is basically just like a YouTube of drone survey and all things propeller. Professionally done videos. They're not cringy. They're very sleek, clean, and informative content there. I highly recommend those. I still use the training videos frequently if I need to check something. And then you've also got access to webinars like this. We do these webinars every couple weeks, and so they're available as recordings in there as well. There's also a contact support button here. So if you ever need to reach anyone, 24/7, you can start a thread in that contact support. It's going to take you through like a type form to triage who needs to, address the issues that you're having or the information that you need. And then people will be CC'd and brought into the conversation as needed. So really good option for that 24/7 support. We have different hardware support lines in the US, Australia, and Europe. This is that information here. This is all available on our website. But if you want to get in touch with hardware support, this email address right here spans across all of these. And then we also have technical support is kind of a newer support channel offered for more of those nitty-gritty technical issues that people may be having or just want to do some troubleshooting or have a very technical question. It can be submitted there. All right, so we can open it up to some Q&A now. It's about a half hour of going through data collection practices, just touching on those best practices. That's a really good high-level overview. But yeah, we would really be interested in hearing any questions that you may have right now.
Just before we jump into the questions, I know right at the beginning of the session, Ian mentioned that we're not going to go into drone specific kind of mission planning on this, but the Help Center and the Propeller U that Ian just pointed out are a great place to start. So there's drone specific mission planning articles and videos there for all the common drones, excuse me, and the drones that we support. So head over there for the specific mission planning settings. They're all screenshots listed out real clear. You can, I mean, the first time people do it, I always recommend sit with your controller and literally step by step follow it through. It's hard to go wrong, really straightforward stuff. So yeah, that combined with this session should hopefully set you up for success. Cool. Well, I've got a couple of questions here, so I can start. The first one is, what if I don't have phone signal to upload my AP AeroPoint survey in the field? Great question, and can happen. We have some known black spots in the UK for signal. So what happens when you turn the AeroPoint out of what's called logging mode and into that networking mode that Ian said is when the network light's flashing, it's searching for the propeller network by default, unless you've customized that using the app. Now, if there isn't a hotspot to be found because you haven't got the signal to set one up, eventually that will just time out. No worries there. Now that you've turned it out of logging mode, you can move the AeroPoint so you can, back in the backpack or back in the truck, head back to the office, or to move to an area where you do have signal. And then if the AeroPoint has turned off because it's timed out, then you've simply got to turn it back on again and press the same button immediately again to put it back into networking mode to search again for that hotspot. So it shouldn't cause you an issue as long as you don't move it before you press that button to stop the logging mode. And the
Yeah,
same
great point.
applies. Yeah, and the same applies if you're going to use that custom option, like Ian said, connect to your office Wi-Fi, for example, then you'd want to follow that anyway. Just leave it in that networking mode until you head back to the office.
Yeah. Another one is good point here. Someone had a question. How do I connect the drone to the AeroPoint? The drone and the AeroPoints actually aren't connected. They're completely independent data collection sources. So the AeroPoints, when they're on the ground and they're doing their thing, they are just refining their position with GPS data completely independent of the drone. So you don't have to worry about connecting, a third-party drone to an AeroPoint or vice versa. There are two different data collection channels, and they get uploaded together and combined in our processing backend. And this is actually a good thing. This allows us to do more troubleshooting. Our data success specialists and that team, very good at what they do. And if they can take these independent sources of data and really get into the nitty-gritty and troubleshoot your data much better and provide you a better product with those two independent sources of collection. So, if the drone falls out of the air or something because of inclement weather, that doesn't affect the AeroPoint survey. If an AeroPoint gets run over because someone wasn't paying attention, that's not going to have any effect on your drone survey data. So keeping those things independent of one another has proven to be a really big asset for us and keeps things simple in the back end for the best product possible.
Yeah, absolutely. The main thing is that the drone flight occurs during the AeroPoint survey, right? So as long as they're both doing their thing at the same time, as Ian said, easiest workflow is to place the AeroPoint down, then worry about flying your mission. And after your post-flight checks, packing everything away, then retrieve the AeroPoint and do the upload. That way, it's hard to go wrong. Cool. So I've got another one which probably came in before you covered this. I use the app, the AeroPoint app, I assume, to upload the AeroPoint data. As Ian covered, it's not necessary to do that, right? So the AeroPoint will happily upload the data via your hotspot without the app. The app is just a great way of, I suppose, monitoring what the AeroPoint is doing and giving you that visual cue on the phone of what's happening. When it goes into that networking mode, it will say searching for network. It gives you a little progress bar of the data being uploaded, and then I think they even do a quick firmware check if there's any firmware to be updated over the air before it then turns off. So just, a little bit more information than the LEDs on the AeroPoint itself, but it is not a requirement for uploading your data. What else we got here?
I can cover this one real quick. We actually did cover this in the webinar. Using regular ground control points with arrow points.
Mhm.
Yes, absolutely. Highly encouraged. You don't need to, like I mentioned, arrow points, one's going to cover 100 acres. I think that's like 60 hectares, if I'm not mistaken, Ben. And then, we can scale up as projects get bigger. But you can always supplement traditional ground control in with an arrow point. So when we upload that data into the platform, there's an option to use just arrow points, just standard ground control, even if you wanted to. We highly recommend arrow points for that high accuracy PPK workflow, or a combination of the two, which is very typical. We see a lot of customers doing that, and really all you need is a CSV file with your name of the point, northing, easting elevation, to that target that's visible on the ground. And again, if they're not visible, still bring those coordinates in that CSV file, and we'll upload those as checkpoints. It's just hitting a drop-down menu for each of those coordinates that we've brought in. Super easy workflow in the uploader. It becomes about a 3-minute process of muscle memory once you get used to bringing data into the uploader. So yeah, 100%. If you have traditional ground control out on your project, let's continue to use that. We'll just supplement the AeroPoints with it.
Yeah, absolutely. There's two more to go through then. One more I can see. What's the difference between a GCP and a checkpoint? Again, covered that earlier on in the presentation here. So the GCP is what's going to be used to help position your model, right? Your process data, whereas the checkpoints won't be used to do that, but it will be used or will be presented to you, should I say, in your processing report afterwards to give you an idea of how the model, the final result of the model compares to your data that you recorded with your rover, for example, out in the field. So it's quite nice to use them in that respect, because when you are presented with your processing report, once the data arrives back in your portal, you have both the accuracy checks for your GCPs, but then also those independent checks for the checkpoints included in the same report, which is always nice to have them in one place.
Yeah, 100%. I've got one here. What do I do if my AP gets moved? My that's AeroPoint gets moved, turned off, or stolen. I have had some customers report to me that some AeroPoints walked off, like a civil project along a roadway kind of thing. Just let us know if it gets stolen. We'll mark it as stolen in the back end. And if that arrow point ever shows up in our system again, it will be identified as a stolen arrow point, and we'll do our best to get that back to you or let you know about it. Or contact whoever uploaded it. I don't think we've ever seen a arrow point that's walked off ever resurface back in the system, but we're waiting for that day to come, I guess. So if it gets turned off midway through a flight, or just slightly before, I encourage users to still upload that data, and our processing team will diagnose that particular arrow point and see if there's anything usable there. If not, don't worry about it. We can just remove that arrow point from the survey and then upload the rest of the data. If it's the only arrow point that you had on site, it may be usable data, but I would expect to refly that project if it's the only arrow point. And these days with drones like the Mavic 3 Enterprise or a bigger, faster platform, that data collection, if there's just one arrow point on a project of that size, is pretty quick. So you should be able to knock that flight out pretty quickly again. And if it gets moved, kind of the same thing. We'll assess. Sometimes they can trim a little bit of that data, but ideally we would just remove that arrow point from the overall survey and go with the rest of the arrow points or existing ground control. But we've got options is basically the short end of that answer there. Upload everything that you have, and we'll triage after that and give you the best product possible. So really don't stress it too much.
I think that is where having that supplementary, either additional arrow points or GCPs can help, right? Because it gives you that redundancy,
Yeah.
just in case the worst does happen with one, and it does get moved or the data isn't usable. So yeah, like Ian said, not all is not lost necessarily. We'll do what we can with what you did manage to capture.
Yeah, and I don't think we have any more questions here. Well, want to say thanks for attending the webinar. We've got more of these, and these get uploaded to the video library. So feel free to go back and look at previous webinars for whatever content you're looking for, and explore the Propeller U video library in there as well. Great resource. And if you are currently a customer, you can reach out using that contact support button. And we look forward to hearing from you. Thanks for joining the webinar. Thanks, Ben. Have a
Thank
good one.
you.
And I hit stop share.